This time, let's talk about limits involving infinity. So I have a rational function here, and to make this go a little bit faster, I did go ahead and graphed it already for you, and I also have the table here for you. So let's take a look and see what we are asked to find. So first one, we are asked to find the limit of f of x as x approaches what number? X approaches positive 2 from left, right? So let's take a look at the graph because I already have that graph for you. So if you look at the graph right here, we have a vertical asymptote at x equals 2. I'll go ahead and use a dotted line for that. We have a vertical asymptote at x equals 2. So we start somewhere on the left of 2. We start somewhere on the left of 2, and let's try to get really close to 2. What happened? As you see, as we approach that blue line, that 2 from the left, can you guys see that the graph just goes straight down? Down to what? Negative infinity. So as the graph, this piece of rational function, is approaching the vertical asymptote 2 from the left, we can see that it goes straight down to negative infinity. So graphically, by looking at the graph, we know that the first answer is x equal, the limit equals negative infinity because it goes down. Let's try to do one numerically, okay? What is a number that is smaller than a number that is smaller than 2, but really close to 2 is, I'm gonna be not that creative. How about 1.99? Wouldn't you say that number is to the left of 2, but it's really close to 2, right? Let's plug in 1.99 into this function and check this numerically, okay? What is f of 1.99? That is 1 over 1.99 minus 2. I'm going to go ahead and use a calculator for this, okay? I'll open one up. I'll try to copy an arrow here. Desmo Scientific Calculator, and I will do 1 over 1.99 minus 2. Look at that number. That is 100. Whoopsies. That's not positive 100. That's negative 100. So what if we get really close to 2? How about this time, instead of 1.99, how about I do 1.999 minus 2? Oh, that's negative 1,000. What if we do get closer, okay? 1.9999 minus 2. You see what I mean? The numbers, the y values are getting smaller and smaller from negative 100 to negative 1,000, negative 10,000. And if we get really close, like 1.9999999 minus 2, look at that. We can see numerically that it's actually going to negative infinity. So graphically and both numerically, we confirm that as x approaches 2 from the left, the limit is going to negative infinity. How about from the right? Let's try that. So how about as x approaches 2 from the right side of 2? Okay, x approaches 2 from the right. Okay, so let me go find my graph right here. So here's my graph. And I start somewhere on the right side of the 2. And I'm going to try to get really close to that dotted vertical line. But look, as it gets closer to that vertical line, as it gets closer to the x value of 2, you see that the graph skyrockets up, right? So that's going up to positive infinity. So I'll go ahead and say that the limit of f of x as x approaches 2 from the right is equal to positive infinity. Okay, because it went up. Now you can try to plug in a number. what is a number that is really close to 2, but it is on the right side of 2? Okay, how about we try, let x equals 2.0001. Right, that's pretty close, right? If I plug this into the function to check this numerically, f of 2.0001 will come out to be 1 over 2.0001 minus 1. Whoopsie, that's 2. And if I use my scientific calculator to just kind of do that really quick, but it died. All right, hold on. I'll go bring that back. While I do that, I'll go ahead and type this here. 1 over 2.000. I forgot the number of zeros I put. But can you see? This time the numbers are getting big, right? I can put another 0 in between. I'll copy this. You see the numbers are getting big, right? As we get closer and closer to 2, it's getting so big they have to use scientific notation. It's going to positive infinity now. It's so big, this calculator's like, oh, I don't want to define that for you. But we know at that point, we can tell that it's going to positive infinity. So we looked at two one-sided limit. From the left, it was going down to negative infinity. From the right, it was going up to positive infinity. So let's go ahead and find a general limit, or we can talk about that. All right, give me 1 second. I was just having a bad connection moment. Well, we saw that when we plug this in, I forgot the actual numerical value. Can I just say a really big number? Really big positive number, right? That kind of confirms that, what we saw on the graph, it matches. As x gets really close to 2 from above, from the bigger number, from the right, f of x, or the limit, the f of x is approaching positive infinity. So they're asking for the general limit now. Thus, limit of f of x as x approaches 2. Now this time we have to look at both sides, right? Does it exist? Yes or no? What do you think? We're going to have to say no. This limit does not exist. Limit as x approaches 2 does not exist. Why? Because the left hand limit, oopsie, not left head, left hand limit does not equal to the right. You know what? Let me go ahead and abbreviate this, okay? Because left hand limit does not equal to right hand limit. Okay? That's why the general limit does not exist. Okay? Alrighty. So that was one example. And I have what we just kind of saw on our Desmos calculator organized in these nice tables so that you can see the graphical method and the numerical method both matches what we found. So let me keep on going, okay? We can do one more example of limit involving infinity right here. Now, did they give us a graph or picture for a graph or table for this? Yeah, they did down here, they did. But I think these are slightly different. So let's take a look. So let f of x equals 1 over x. It says find limit of f of x as x approaches what? X approaches, let me highlight this. This is so important. Okay. X approaches positive infinity? What does that mean? Okay, now that means x is just gonna get really, really, really big, right? Really, really big. And where do we find these big numbers on the number line? To the right. So what they are asking over here is this is just asking for the right end behavior of this function f of x. Because where do we find like 1,000 or 1,000,000? It's on the right side of the number line, right? Because on the number line, we put small numbers on the left, and as you go to the right, dot, 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 if you go to the right, that's where you find the big numbers. So what they mean by x approaches positive infinity, they're asking you to find the right-hand behavior of this graph. So I'm going to go take a look at this picture over here. So as you follow this graph to the right, keep on going, can you see this rational function has a horizontal asymptote? And that's something that you learned in pre-calculus, right? We can see that curve, that purple curve, is kind of slowing down. And we can see that we have a horizontal asymptote at y equals 0. Okay, so graphically, I can see that the limit is 0. I think I typed the answer over there too. But why? Why is that happening? Let's take a look at that numerically, okay? So we know that the answer is 0, but why? Okay, I want to know. So let's check this numerically, okay? Plug in a really big number. Plug in a really big number. What am I doing? I'm trying to simulate like positive infinity, like x equals 10,000. For me, 10,000 is pretty big, okay? What happens if I plug in 10,000 into this function? F of 10,000 is equal to 1 divided by 10,000. Imagine you have $1 and you're trying to divide this into 10,000 people. Each of them get like nothing, right? So let me see. I'll show you. I have my calculators. If I type in 1 divided by 10,000, that comes out. It's so small, like they're using a scientific notation, right? But even if I just show you like 1 divided by 1,000, that's 0.001. So if I divide 1 divided by 10,000, that must be 0.0001. But hopefully that convinced you that if you divide 1 by a big number, that's almost 0. So as x gets really big, we're dividing $1 by a really big number. So each of these people get nothing. So that's why as x gets really big, the limit is approaching 0. How about let's try the left end, okay? What they mean by as x approaches negative infinity. This is asking you for the left end behavior of f of x. Because negative infinity means smaller numbers. And where do you keep these smaller numbers on the number line? On the left side, right? So look at the graph. As you follow this graph to the left, it's going up from the bottom, but can you see that it's getting really, really close to 0 again? Because we have a horizontal asymptote at y equals 0 for this graph, okay? So the answer is 0 again. Answer is 0 again. And if you want to check this again, try to plug in a really small number. Try to plug in like negative 1,000 into this function and see what that number looks like. What is 1 divided by 1,000? What is 1 divided by 1,000? That comes out to be negative 0.001. And I know it's a negative number, but do you agree that number looks a lot like 0, right? It's getting really close to 0 from the bottom. So both graphically and numerically, we evaluated where the function is going as x approaches positive infinity. Okay, go from 100 to 1,000 to 10,000. Or as x goes to negative infinity, like negative 100, negative 1,000, and negative 10,000. And we notice that the both right end and the left ends are approaching its horizontal asymptote of y equals 0. So that was interesting. So we looked at 2 examples in this about, how long was this video? In this about like 15-minute video, we looked at 2 examples involving limits involving infinities. So hopefully those made sense. On our very last video together this week, we will talk about, you know what, I think we have another example, but I think I'm going to cut this video here so that I can start example 3 in a new one, okay?